Hello, and welcome back to Looking Up at the Big Sky. I'm Katie Aiello with U.S. Fish and Wildlife Service at Charles M. Russell National Wildlife Refuge. And with me are Virginia Rooks with the Glasgow office of the National Weather Service and Sue Dalby with the U.S. Army Corps of Engineers at the Fort Peck Interpretive Center. If you haven't yet, tell us where you are joining from in the comments. If you have any questions throughout tonight's presentation, please type them in the comments section. We will be able to respond to all of your questions during and after the presentation. Tonight, we are going to be exploring objects we can see in the dark sky, because we should have some excellent night sky viewing this weekend if skies stay clear, because we have a new moon tonight.
One of the first star-like objects to appear at twilight are planets. Planets are typically brighter than stars in the night sky and generally don't twinkle like stars do. This is because the planets are much closer to Earth than the stars. Planets will appear to shine a pretty steady, bright light. It can be a little tricky to notice this at first if you're not used to looking up at the big sky for planets. Starlight particles traveling to Earth has astronomically more air to pass through than our planetary neighbors, making extremely small interactions with air particles as it makes its journey through space and our atmosphere to reach our eyes on Earth. As twilight transitions to night, more stars will appear, but the planets will remain bright. In this photo, you can see the great junction of Saturn and Jupiter that occurred last December when the planets made a very close approach. Jupiter is brighter than Saturn, but both planets are relatively brighter than the stars that are beginning to appear within this photo. The word planet in Greek means wanderer. That's because the planets don't move in the same way that stars do, and throughout the year tend to retrograde or wander backwards for some time. Stars, on the other hand, will consistently move from east to west along the ecliptic plane. Consider the planets relative to Earth and the Sun. The inner planets, Venus and Mercury, can be seen near the proximity of the Sun. Mercury is the planet closest to the Sun, so it is usually briefly seen near the horizon. The outer planets, Mars, Jupiter, and Saturn, can be seen in different locations in the sky and at any time of the night throughout most of the year. Here's an idea of what Mars, Jupiter, and Saturn looks like in a typical home telescope. It's difficult to see moons of Saturn, but you should be able to see Saturn's rings extending from the sides and the tilt of its rings. You can also see the biggest moons of Jupiter in both binoculars or a telescope. When the planets are visible, Venus is usually the brightest object to the west around sunset and to the east during sunrise. Mercury is tougher to spot because it's much closer to the Sun and near the horizon at sunrise and sunset. Mars has an orange-red hue and looks a lot like a large star that doesn't twinkle. Jupiter is the second brightest planet in the sky and can be seen throughout the night. Saturn is the third brightest and is sometimes out whenever Jupiter is too.
Did you know we live on a giant satellite? But probably not the kind that you're thinking of. A satellite is anything that orbits a star or planet. So because the Earth orbits the Sun, which is a giant star, it is a satellite. The Earth also has many satellites that rotate around it. The Moon is the most visible, but there are thousands of artificial satellites that rotate the Earth. These satellites keep us connected to friends and family by providing phone service. Satellites that provide internet and TV keep us entertained, and research satellites like the International Space Station and the Hubble telescope keep us informed. There are two kinds of satellites, polar orbiting and geostationary. Polar orbiting satellites travel from pole to pole and may appear as a fast-moving pinpoint of light on very dark nights. Contrary to their name, geostationary satellites do move. However, they travel east to west along the equator at the same rate of the Earth's rotation, so they appear still. And even in the darkest skies, they will only be visible with a telescope. Not sure if you're looking at a satellite, meteor, or plane? Pay attention to these three things: blinking, speed, and consistency. Planes will have blinking red lights, and they move more slowly across the sky. Shooting stars and satellites move quickly across the sky, but satellites will be consistently bright, while a meteor will brighten and dim as it enters Earth's atmosphere.
The Milky Way Galaxy is where we call home in the universe. This is what our galaxy is believed to look like: a young, barred, spiral galaxy. Imagine trying to map out your house from sitting in only one room. You can use a lot of hints and cues to formulate an idea of what the rest of the house would look like, but it is not as easy as it could be if you could view it from above or explore each area. Astrophysicists have to do something similar using technology to look at segments of the galaxy and then try to piece the puzzle together. Although the Milky Way has been visible to the naked eye since the dawn of time, light pollution has been a problem for many populated areas. About a third of all humanity and roughly 80% of Americans live in an area with too much light pollution to be able to really see the Milky Way. Here in Northeast Montana, we are so fortunate to live in one of the darkest locations, so you don't have to go far to be able to look up and let your eyes adjust. The Milky Way will look like a fuzzy, patchy cloud of faint stars that run from a north to south orientation in the sky.
Speaking of home, how did people historically return home or explore using the North Star for navigation?
Well, Katie, that's a great question. The Earth spins on an axis, and that axis is an imaginary line running north and south through the Earth. If that line is extended into space from the northern hemisphere, that line points toward the North Star, or Polaris. From Earth, the stars seem to rotate around the North Star. From our perspective on Earth, the North Star always stays in the same northerly direction, so it can be used for navigation.
How do we find the North Star?
Well, though it is about 433 light years away, it can be seen with the naked eye. Based on its name, we know it's in the northern sky. The North Star is part of the constellation Ursa Minor, which means little bear in Latin. The stars are in the shape of a cup with a long handle, or the Little Dipper. The cup is the bear's body, and the handle forms a long tail. The easiest way to find Ursa Minor is to find Ursa Major, or the Big Dipper, which is somewhat brighter. So if we extend a line between the two stars at the end of the Big Dipper cup, we will find Polaris, or the North Star, which is the end of the Little Dipper's handle.
Ursa Minor and Ursa Major are just two constellations that are visible in the night sky. A constellation is a group of stars that form some kind of discernible shape or pattern. In previous lessons, we have discussed how Latin is a universal language for scientists. Well, there is also a universal set of constellations recognized by astronomers. The International Astronomical Union, or IAU, recognizes 88 constellations. These form animals, objects, and mythical figures. Many of the stories surrounding these constellations originated in ancient Sumerian, Babylonian, and Greek cultures. However, ancient and modern cultures around the world have their own unique constellations and stories that are not a part of the official IAU constellation list. The Big Dipper is an asterism, or pattern, inside the IAU recognized constellation Ursa Major. Many sky cultures have their own constellations formed by the same 7 stars. In Belarus, it is Elias's cart, and in Inuit culture, it is a caribou. However, in other cultures, additional stars are added to form very different looking constellations. For example, the Navajo see the revolving man, and the Ojibwe see the great fisher. Other sky cultures do not recognize any patterns in the stars that form the Big Dipper. If you are interested in learning about other sky cultures, check out the link in the comments section. You probably already know how to find the Big Dipper, but what about other constellations? Let's go outside and learn about a simple tool you can use to find constellations any time of year.
This is a planisphere, a simple, low-tech tool you can use to locate constellations in the night sky. We've shared the link to this free planisphere in the comments section so you can print and make your own at home. Planispheres vary slightly by latitude. Be sure you select one that most closely matches the latitude at which you will be using it. I've chosen 50 degrees because the Glasgow Fort Peck area is at 48 degrees north. Rotate the wheel until the date is aligned with the time. If you are in an area that follows daylight savings time, you will need to subtract 1 hour on your planisphere. Grab a red light headlamp or flashlight and head outside. I can find the Big Dipper without the planisphere, so I am going to look for that one first to help me orient my direction. I will turn towards the Dipper and rotate the planisphere so the direction of the Big Dipper on the planisphere matches what I see in the sky. Now I can turn north. As I do so, I will rotate the entire planisphere so north is at the bottom of my field of view. I'm going to see if I can locate Cassiopeia because that constellation has lots of bright stars. This time of night, Cassiopeia will appear as a W. However, later in the night, it will appear as the letter M. To find Cassiopeia, I will rotate my planisphere slightly so northeast is at the bottom of the viewing window, and I will turn to face that direction. Even though I live in town and have bright street lights outside of my yard, I can see Cassiopeia. If I want to look at stars in the southern sky, I will rotate the planisphere so it is upside down with south at the bottom of the viewing window. Let us know if you were able to locate constellations using a planisphere.
Since the new moon in July offers really dark skies, the Milky Way and constellations are easy to see. As you can see by this light pollution map, most of northeast Montana or Missouri River Country tourism region offers lots of dark skies for gazing. Fort Peck Reservoir and the Charles M. Russell Wildlife Refuge offer many recreation areas to observe these night skies.
Virginia, what kind of weather can we expect if we're going to go out and try and find some constellations this weekend?
Well, we've been so hot and dry lately, and overall that trend is not going to change much. For the extended outlook produced on July 4th, the weather will generally have a greater than 40% chance of being below normal precipitation and above normal temperatures. Highs are expected to be in the upper 80s to lower 90s this weekend with lows near 60. And although it'll be generally hot and dry, there will be several opportunities for a slight chance of showers and thunderstorms throughout the weekend. As usual, check out the forecast before heading out to explore when you're looking up at the big sky. Don't forget to double check fire restrictions for the area you are exploring and have a safety plan in case you are caught in a thunderstorm. If you end up having too much cloud cover this month, the next new moon this summer will be on the evening of August 7th.
If you get out to explore the night sky, we would love to see or hear about it. Please share any photos or viewing experiences with us using the hashtag looking up at the big sky. This will be our last virtual astronomy program for this summer, but stay tuned to the Fort Peck Project Facebook page for updates on future versions of this program, informational posts, and maybe even some night sky photography. Before we sign off for the evening, Sue and I would like to extend a big thanks to Virginia for being the brains behind this program. She is moving forward to another position with the National Weather Service, and while we are sad to see her go, we are excited for her next adventure in Alaska. Virginia, what are you most excited to see when you go looking up at the big sky in Alaska?
Much of the night sky phenomena visible in Alaska was also visible in Glasgow, Montana. The difference is that the aurora will be a little higher in the sky and maybe more intense at times. But I'm also very excited to see how much daylight changes with the seasons throughout the year.
We are so excited for you. And thanks to our audience for joining us this evening. We will be sticking around for a few minutes to answer questions in the comments, and we hope all of you keep looking up at the big sky.